続きましての講演です。続きましては、チョン・クアン・チェンさん、インディ・リーさん、シャンデー・ジャンさんからオペレーション・キメラ、半導体ベンダーをターゲットにした APT 攻撃についてお話をいただきます。サイクラフトエンジニアによる半導体業界で約2年間発生した持続的標的型攻撃 APT の分析です。今回のテーマにつきましては動画をいただいております。Our next session is Operation Chimera, APT operation targets semiconductor vendors. Please welcome our speakers, Chang Kwan Chen, Indy Lin, Shande Jen. Please start.
Hello everyone, I'm CK. Very happy to come to Kopu and sharing our research. Today our topic is Operation Chimera, APT operation targets semiconductor industry. So first, let's introduce ourselves. I'm CK Chen. You can just call me CK. I'm a senior researcher at Cycraft. I'm responsible for our research team. In the past, I'm a CTF player and founded the Bamboo Fox CTF team and joined the DEFCON final for twice. I'm very active in the community. So currently I'm the HICOM and HITB review board and be a member of one of a top private hack group in Taiwan that called CHRoot. My partner, Shante Zhang, is a security researcher, and he also founded a Taiwan local hacker group called UCCU. And Indy Lin, who is a security researcher and focuses on reverse engineering and malware analysis. And he has published several research in HICOM and RUCOM. And our company is Cycraft. And it's a startup company that moved to the third year. And we're trying to use the AI and machine learning to solve a lot of security problems, such as APT investigation, threat hunting, and threat intelligence. And here is three of our systems. The Zensor is our threat hunting system that collects information in the endpoint. The CyberTotal is a platform for the threat intelligence. And this information will be feedback to the Cycraft, which is a core of our APT investigation. So these three systems help us a lot to track in the APT campaign, just like we will mention today. And we also joined the MITRE ATT and CK evaluation in the last year and get a very nice result. If you are interested about that, you can follow our white paper in our blog. So come back to our today's topic. This is today's outline. Since Taiwan has a very special political situation, so we face a lot of cyber attack every year. In 2018, we have the TSMC ransomware. TSMC is the largest semiconductor vendors in Taiwan. In this attack, their production line is held down for 2 days and cost about $170 million. So this attack shows that even so, the isolated environment is possibly to be compromised. In the 2019, the ASUS supply chain attack happened, and we called it Shadow Hammer and first discovered by Kaspersky. And this attack put the millions users in the risk. In this year, the most critical incident to Taiwan is a cold lock attack to the CPC. And CPC is our main company of the energy sector and has a lot of gas stations. So during the attack, this gas station cannot provide their payment service. So this attack not only bring the inconvenience to the users, but also show the attacker's capability to shut down this kind of critical infrastructure. And compared to semiconductor landscape, with the decades of development, Taiwan has become the leadership in this field. In 2019, our IC market share is in the 4th place, and the wafer capacity is taking the 1st place in the world. So, and according to the Taiwan News report, we are the largest and fast-growing semiconductor equipment maker and take about 12 million revenue. So this shows that Taiwan plays a very important role in the global semiconductor landscape. So we monitor this attack between 2018 and 2019. We discovered that several semiconductor vendors is being compromised. And most of the vendor is located at Hsinchu Science Park. And Hsinchu Science Park is an area that a lot of Taiwan's high-tech vendors located in. So we can say it's a century of Taiwan high-tech vendors, and especially for the semiconductor vendors. And we will say this attack is an intensive attack. After we published our white paper in April this year, we received a lot of feedback, and we know that there are more than 7 vendors is being targeted. And we also published our research in the Black Hat this year. And after we published a report, just in the 2 months, we identified the other victim. So now we know there are more than 8 semiconductor vendors is being attacked. And some vendor is not only attacked Taiwan, and some vendor in Europe is also being attacked. In the last part that we want to say is that this attack not only attack important vendors in Taiwan, and also attack their subsidiaries, competitors, and the supply chain. So we will say that the attack moving from attacking the single point, single enterprise, to attack the supply chain. And now they are trying to attack the entire industry surface. So we call this group the Chimera. That's because their activity, their technique, and malware were very similar. So we believe that this attack will work of the same threat actor. And their main target is the semiconductor vendors. And they widely to use a malware that merge from the open source and open tool, like a dumper, Mimikatz, and commercial tool, Cobotrike. And their C2 is hosted in the public cloud to avoid attribution. And their goal is trying to steal the document, source code, SDK, about some project related to the chip. So today, we will tell you the more detail about the attack. So we first will go through several case studies. So we will share the 3 case studies. Yeah. Not only because these 3 vendors are the leading global position in their own market segment, but also because now we involve the investigation in a different time point. So the analytical perspective of the attack campaign was also different. For the A company is our long-term partner, so we can track in the more detail about attackers' activities. And this information enables us to track it back to the root cause. In the B company, it's a one-time IR service. So when we start the investigation, the attack is finished and has happened for a long time. So we cannot recover everything back. But however, we can highlight the long-term activities and identify what kind of data was leaked. And for the C company, it's also our long-term partner. And however, they have a very high-skill security team. So they can help us to dig more. So give a lot of feedback and help us to illustrate and profile the threat actor. So next, we will turn to John's part. John will help us to introduce the case study.
Thanks, DK. So I'm next presenter, so I will introduce 2 case study. And the first case study is our long-term partner. So the threat actor only enter the environment in 1 day, and the 50 endpoint and 6 user account were compromised. And the 4 malware and the HC2 server we found. And the right-hand side is our AI generator, the graph, the flow, and tell the investigator what happened in the environment and how the threat actor later move on to other endpoint. And the first model we found is the Cobalt Strike beacon. And the Cobalt Strike beacon pertain as the Google update. And we searched on the files total and we found nothing on the files total. And the Cobalt Strike beacon will inject the payload into another process. And we found that there's two endpoints, server Lauro and APT China has the Cobalt Strike beacon. And just like previous I say, we found the pretend as a Google update. So the Slater use the hosting server for their C2 and use a Google Cloud platform. And there's an interesting point is the first day the Cobalt Strike beacon will connect to the Google update, but the second day after they move on to another endpoint, the Cobalt Strike beacon has changed the hosting server to other cloud platform. So while the Slater has switched the cloud hosting service, so in our investigation opinion, we think because the thread header has a multiple operator, and the second day the different operator has preferred their different hosting server. So that's why they changed the hosting service. And we found, based on our tenant analysis, we found the backdoor in APT China was implemented from the server Lauro. So we traced back to the server Lauro and then we found some remote execution tools. One is a schedule tester and another one is WMIC. So they use a schedule task to deploy the Cobalt Strike beacon, and they use a WMIC to check can they not later move on to another endpoint and check the endpoint has an internet connection. So based on the remote execution tool execution history, so we quick draw the server Lauro later movement to another 3 endpoint. But why the server Lauro has this behavior? So we check, and we also notice the server Lauro has a remote collect the registry and the NTDS data in the AD domain controller. So why the thread has collected these two files? Because the NTDS data is a Windows AD database, so it stores the password, email account, and the name and the ID. But all the information are encrypted, so they need the key to decrypt. So the key is stored in the registry. So that's why the thread editor has need to collect these two files. So based on our correlation analysis, so we found that MB layer has a schedule task execute to the server Lauro. So MB layer must be the source. So we check into the MB layer. So we notice before the thread before the later movement to a server Lauro, that has a 6 minutes before the scheduled task execution. That's IP1 has used RDP and the user D01 to make a successful login to the MB layer. So it's very highly possible to the cause of this attack. So we notice the threat actor has once they into the environment, they use a net user to do the Windows AD discovery, and it is a very strange because once they RDP success login, they do this very quickly. So I think so. In our investigation opinion, so we think this that's the best practice was once they get an environment, what's the recon action they need to do. So the thread also use 1 byte modified IR to collect the intelligence property, and we found a lot of the same file in the environment, and it highly has been used in the past attack. So based on the previous finding, we named this as Operation Chimera. So look, we track back to Chimera, what's the IP1, but based on our finding, the IP1 is probably a share host or VPN host IP. So we cannot track it into the IP1. So the second component is IR case. So the Bitcoin has been compromised, and the Bitcoin and the C component has a business collaboration. So BC component has do some network internet connection, and the C component asking us to investigate the B component. So the threat actor has totally has a 1 year was compromised at least 1 year in the Bitcoin. So we found a PowerShell, and the threat also used the Cobalt Strike beacon, but this time they use a PowerShell to inject the Cobalt Strike beacon. And the Cobalt Strike beacon will inject the malware to the instance, and they also use a hosting server in this operation, but this time they use Microsoft Azure hosting service. And just like previously, the hacker added this into the environment Bitcoin at 1 year, at least 1 year. So Bitcoin has a serious hack. So the screenshot is our AI generated cybersecurity graph. So as you can see, it totally have a mess in the environment. So the threat has entered in the environment at 2018 November, and the interesting point is the hacker return in the environment every quarterly to collect the new data. And the 2019 November, they deployed a new weapon we call a skeleton injector, and our colleague Indy will introduce this later on. And once they deploy the skeleton injector, they harvest the new endpoint. So this represent the skeleton injector has its work in their environment. So why they need to deploy a skeleton injector? That our colleague Indy will introduce later on. And the threat uses archive password. The archive password has a similar schema, and they also use 1 byte modified IAR to collect the file and protect the recorded.ms, JU check, and the firmware log, something like the rigid file in the system. And then based on the leak file name, we do the identify and make a summary, and some of the data is shown below. So they collect the roadmap, a backup workspace, and chip and SDK information, and the product SDK and the installation guide. So based on the thread collect file, so we think the attack intent is stealing intelligence property, not the cracking stuff. So it probably is a business spy or some state-sponsored attack. We are not sure, but one thing we're sure is this threat actor has targeting the semiconductor industry. So this totally both is my part, and I will turn into the CK to introduce a case study C.
But due to the time limitation, we will quickly go through the C company. In C company, they have a very skillful blue team that can help us to track it more deeper and try to profile the threat actor. So during the investigation, we identified some documents that may live by the threat actors. So this is like the cheat sheet to the takers penetration testing. And the command line here makes some activity that we monitor. And this cheat sheet referring to a very famous Chinese website, so Chinese security website. So in this part, we can say that the Chimera campaign has at least one member that understands Chinese. We also make the statistic about their active time. So we can see they are most active in September and nearly no active in October. And their working hour is from the 8 in the morning to the 8 in the night. So their time zone is look like the UTC plus 8. So next, Indy will show the actor's digital arsenal.
Thanks, CK. Hi, I'm Indy, reverse engineer from Cycraft. Now I'm going to introduce actor's digital arsenal. We have observed these tools they use to carry out this attack. The first we are going to talk about is Cobalt Strike Beacon. Cobalt Strike is a commercial red team operation framework. They use Cobalt Strike Beacon as their primary backdoor in these intrusions. For the persistency, they override Google Chrome update utility with their Cobalt Strike Beacon. Thus, there is no any new auto-run entry was created, so it will lower the chance to be caught. Our product detected some suspicious memory block. The interesting part is that it is a PE file and also a shellcode. Cobalt Strike Beacon and Minterpreter both use this technique, the hybrid payload. This technique is to embed shellcode into the PE file header. The PE magic header MZ could be decoded as valid instructions, and these instructions will work fine in most of context. So you can ignore these instructions and append shellcode after it. The shellcode will locate its address and execute the reflective loader to load PE image in memory. Cobalt Strike uses a special strategy to inject payload into other process. First, Cobalt Strike will spawn a new process or choose an existing process as the target. Then, inject the shellcode into the process, and we call it stager. The real payload will be transferred through namepipe and executed by stager. And this strategy will bypass some sandbox or emulation-based scanning. The WinRR is a popular commercial compression software. It was also used in this operation. The actor used RAR to compress and encrypt the file that's stolen. They try to ambiguate the program with existing file path called recordedtv.library-ms. The reason why we mention this file is this file is different from the original IR.exe. We grab the old version of IR and compare it with the actor used. We found the different part was in code section, and such patch may crash the program. So we think it may be intended to change the hash and avoid the detection. Another hypothesis is it is just a bit flip during copy. Now we are going to talk about the most interesting malware used in this operation, the scalar key injector. We found a unique malware that was made with two open source hacking tools, a Dumpert and the Mimikat. Okay, so maybe you don't know Dumpert. It is a program to use direct system call on Windows. Unlike Linux, Windows cannot direct use system call in shellcode because the syscall number will change from release to release. The only stable interface is exported function from the shell libraries. That's why Windows shellcode must rely on them and always start by locating functions and parse data in memory. So, How do dumper doing it? First, it uses RTL get version to determine Windows version and select different embedded syscall functions depend on it. After that, you can bypass any user space hook and doing anything you want without triggering any alert. Skeleton Key is an APT malware discovered by Dell SecureWorks in 2015. It will implant a backdoor password to domain controller. Then, attacker can authenticate as any user as they want with the backdoor password. Meanwhile, original password remains untouched. Any other wrong password will still be rejected. Skeleton Key will alter the authentication flow by hooking some crypto functions in lsauce.exe. Original Skeleton Key malware was never released publicly, but the author of Mimikatz still made his own implementation. And Skeleton Key is a very powerful weapon against a Active Directory because you don't need to dump administrator credential for lateral movement. If you use the administrator credential to access endpoints in a domain, you will trigger a lot of alerts. Skeleton Key cannot be removed easily without reboot. It will be painful to reboot domain controller because you may break your organization's daily routine. We also observe some other attack that using modified version of Mimikatz against Taiwan government agencies. Next, we are going to introduce the new finding after the white paper published. We found WinT backdoor was used in this operation. At the first time, judged by the command line event log and the program usage, we thought that was a network probing tool. But after detailed analysis, we found that is actually a WinT backdoor because of the magic number used by the WinT backdoors protocol. This is our new finding after Black Hat presentation, the backdoor used before in the CCleaner attack. CCleaner got hacked in 2017. Attacker performed supply chain attack and inject malware into CCleaner installer. If the target was interesting, they will implant second stage backdoor. What we found is a new variant of second stage backdoor used in CCleaner supply chain attack. The file name indicates that they exploited their hijacking vulnerability as persistency method. We will release more detail about this malware soon. Here is the execution flow of this malware. They modify an existing share library and Trojanize it by inject malicious code into its body. The original name was vnicAPI.dll. The modified C runtime will execute shellcode collector, which will concatenate spreaded shellcode pieces in the body and execute it. The collected shellcode will read the real payload from MUI file. The real payload is an obfuscated and compressed PE loader. It will unpack itself and execute the embedded PE filelessly. Both these two malware was modified by patching existing DLL file, so most of the content remains untouched. Only a little part was modified. Here is the difference between this malware and the one used in CCleaner. I have unpacked and dumped the embedded PE from the obfuscated shellcode. The biggest difference is how they obtain C2 host information and their capability. The new malware has a hard-coded C2 IP address, and it uses a new method to decode data they grabbed from GitHub. Also, the new malware has more capability, which can replace a file and execute command. This is the end of malware analysis part. Now, CK will make a conclusion for us about this talk.
So it come back to my turn, and in the final, we just want to give some conclusion and the takeaway. So Today's presentation, we disclosure large-scale APT attacks target semiconductor vendors, and more than 8 vendors are being compromised. We will say this attack is precisely attack and target the leading semiconductor vendors, their subsidiaries, partners, supply chain, and competitors. And their goal is steal intelligent property, like a document, source code, and SDK, which will make a long-term damage to the victim. And for the technical part, the attack widely utilize some open source or general tool to make their own malware. So this will make the attribution more harder. In the 2 case study, we can see the AD and VPN are compromised. So the enterprises should consider the resilience about their IT systems, avoiding relying on a single security service. When we investigation this attack, a rarely used guarantee attack is used, which make the adversaries log in like normal users. So this can be used for a persistent and defense evasive purpose. So the final, no system is safe. So we need to regularly do the threat hunting and shorten the mean time to detect and mean time to response. So this is our today's talk, and thank you for your listening.